name is Tanmayi, and this is my individual reading for the HRI assignment. I've chosen the paper Visibility Enhancement using Autonomous Multi-Camera Controls with Situational Role Assignment for Teleoperated Work Machines. This paper is by Mitsuhiro Kamikaze, Junhee Yans, Hiroyasu Iwata, and Shigeki Sugano. I would like to first emphasize the critical importance of teleoperation in disaster response. It ensures that operator safety is maintained while having the ability to perform some crucial tasks. Here, the operator has the ability to work in environments that cannot sustain human life. So the operator gets to work from a safe remote distance during some dangerous tasks. So while teleoperation solves these major issues, it also introduces new challenges, particularly in the field of efficiency and precision. There is a 40% decrease in efficiency when we see that the system is being controlled by a teleoperated vehicle instead of being in person. So this decrease in efficiency is a significant concern that needs to be addressed. So I'll be explaining the three main factors that affect the performance. Okay. These factors are incomplete visual information, communication delays, and lack of tactile and body sensory information. As we can see, the limitations of current fixed camera systems in teleoperation are significant. And while previous research has made some improvements, such as reducing the number of cameras and monitors and analyzing operator blind spots, it has largely overlooked the potential of adaptive environmental camera systems. So our study addresses a critical gap in the field by proposing an autonomous, situationally aware camera control and selection system. This approach has the potential to significantly enhance operator visibility as well as work efficiency. The methodology of our system lies in the concept of camera roles, which combines the specific imaging objects with specific imaging modes. This allows for flexible and adaptive camera control. The real-time role assignment system is crucial as it continuously evaluates the work situation and assigns the most appropriate roles to the available cameras. For example, the camera roles can include imaging objects, such as the machine, manipulator, and endpoint, and it can have imaging modes such as tracking, zoom, posture, and trajectory. So this kind of dynamic approach can provide operators with the most relevant visual information at any given moment during the teleoperation tasks. So let's discuss the four fundamental camera roles that are established in this paper. First, we have the overview machine. The overview machine uses the imaging modes tracking and zoom and has the function to track the machine with a panoramic image. The purpose of this overview machine is to provide the operators with an understanding of the overall situation. So its features include showing hazards such as approaching machines and nearby objects or terrain, adjusting the angle of view based on the distance between machine and cameras, and ensuring that the whole machine is in the image frame. Now we discussed enlarged endpoint. Here the imaging mode used is once again tracking and zoom, but the function is to track the endpoint with an adjustable zoom, which allows for precise and efficient operations. So the features include having a zoom ratio that can adjust based on the work situation. Then we can also have zoom proportional to the precision necessary for individual operations. And this kind of imaging helps us avoid dangerous collisions during grasping, pressing, and releasing objects. The third role that we will describe is the posture manipulator, or R3. The function here is to maintain the camera at a right angle to the manipulator, and its purpose is to provide the operators with a sense of depth. So here the features of this role include helping avoid unintended contact with obstacles and using the angle sensors and GPS data to determine manipulator positions. Once again, it allows for a perpendicularity range of 90 degrees with some deviation up to 20 degrees. So this 20 degrees is given as the tolerance with which the camera can work with. Camera role we see is the trajectory manipulator, where the imaging mode has tracking, posture, and trajectory, and the function includes tracking the manipulator with an offset in the direction of the endpoint movement. So the purpose here is to provide environmental information for future movements. Features of this particular tool include offset is proportional to the endpoint's velocity, maximum offset is set to 2 meters at the highest velocity, and all this allows for improved safety and efficiency by allowing advanced planning. So these different camera rolls combine specific imaging objects with imaging modes to provide the operators with enhanced visual information suited to different work situations in teleoperation tasks. So, the experiment that the researchers conducted was a comparative study using a VR simulator for debris transport tasks to evaluate the effectiveness of their proposed autonomous camera control system. So, this autonomous camera control system was switching between the 4 different camera rolls that we just discussed. So, they compared 3 systems. One was a fixed camera system, one was the manual camera control system, and the third is this proposed autonomous control camera system that's able to switch between 4 camera rolls. The evaluation criteria included time efficiency, safety, quality of work, and subjective usability. The results showed that the autonomous system performed best among the 3 systems. So we saw a decrease in grasping misses and erroneous contacts. There was increased subjective usability and improved time efficiency. So the results are further discussed in the next slide. So now that we saw what the evaluation criteria was, let's see what the results they presented us with were. We saw that there was a 15% reduction in task completion time when it came to our autonomous system, and a 30% decrease in grasping misses are also noteworthy. We also see that there was a 25% reduced erroneous contact compared to manual control. And when it came to quality of work, we saw that the autonomous system improved precision in object placement by 20% over fixed cameras. So as we can see, the improved precision and reduced collisions highlight the system's ability to enhance work quality. Finally, the higher usability ratings and reduced mental workload indicate that the operators found the system more intuitive and less demanding to use. These findings strongly support the effectiveness of the proposed adaptive camera control system in enhancing teleoperation performance. As we conclude this presentation, I want to highlight the key findings and implications of this research. The autonomous camera control system demonstrated significant improvements in teleoperation performance, particularly in reducing errors and increasing efficiency. Specifically, we saw a decrease in grasping misses and erroneous contacts. We also saw an increased subjective usability reported by operators. So these results suggest that our proposed system can enhance both objective performance metrics and the subjective experience of the operators. However, it's important to acknowledge the limitations of the current implementation. We focused only on the yaw pitch and zoom control, and there was a need for comprehensive operator training, and there's high dependency on technical infrastructure. The research demonstrates significant potential for improving disaster response operations through enhanced teleoperations. The key findings included autonomous camera control system improving both objective and performance metrics, as well as the operator experience. We saw that the system's adaptive approach to camera control and image selection shows promise for reducing operator cognitive load and enhancing situational awareness as well. However, the study also reveals important areas of future research and development, such as optimizing camera placement strategies and incorporating advanced image processing techniques. So this research provides a solid foundation for future advancements in teleoperation systems for disaster response, potentially leading to safer, more efficient, and more effective operations. Thank you.